Assalamualaikum warahmatullahi wabarakatuh. We are from Group H. So today we will present about RF technique and microwave assignment. So my lecturer is Dr. Zakir and this is my teammate Norafika binti Muta. So we assigned to do assignment by using 3.4 GHz cut-off frequency, 40 dB, 7 GHz, 3 dB equal ripple, and 3.5 GHz center frequency by using 360 MHz bandwidth maximum flat and n equal to 4 for the bandpass. So the next slide, this is an introduction. So firstly, a microwave passive filter is type of electronic circuit that used to modify the frequency response of microwave system. The primary function that we know, microwave passive filter provide to perfect transmission of signal within a specific frequency range, not a pass band, while attenuating or blocking signal outside of this range, known as a stop band. Passive filter differ from active filter in that they do not provide signal amplification within the pass band region. Instead, they keep the signal power level constant and slightly reduce it. So lastly, microwave passive filter play an important role that the frequency response of microwave system allowing a specific frequency to pass through while the alternating unwanted signal. So for the low pass filter that we're using ADS and assign that the cut off frequency, insertion loss, ripple frequency, bandwidth, and the bandwidth cut off. So we do a calculation um, for this part and by using equal ripple diagram. So by using this equal ripple diagram that we calculate for the C1, L1, C2, sorry, C1, L2, C3, L4. So we just calculate until G4 because G5 is 1 and we our n is 4. So this is our construction that we do for the assignment for the low pass filter. This is before tuning that we just put the capacitor C1, L2, C3 and L4 by using the 50 impedance. So we get from this circuit design, we setting at 1 gigahertz start, 0 gigahertz start, stop at 10 gigahertz. We just extend that the gigahertz to stop. So this is a not proper low pass, but this is a low pass because that show they show beginning, maintain, and then drop at the 7 gigahertz. So this is our calculation for the distributed designs for Richard transformation. So we using the calculation and do the Richard transformation by using this formula. So firstly, we must figure out the N2, N1, N3, the capacitor, what is the amount, and the capacitor, we must draw the L, the capacitor, then calculate. So This is the M sub for the before tuning. After we calculate this, we will do the circuit design for the M sub. So this is a low pass. So in this slide, we have four. We using M log, just normal lah. M log and others. So from the graph show that from 0 GHz and drop the low pass, and then go to high back. So after tuning by using this, we just setting refer to the transformation that we calculate before that, and this our result. We setting the cm, the length, the width, then get the proper lah, and drop at 7 GHz. This is our design layout for distribution LP design, low pass design. So we design and assign using that I mentioned before. So for this part, nothing to explain because this is simple. Just click the PCB layout and we'll show this. But you must make sure that when you click that the part, make sure the all thing this is highlight. Then we show lah the layout for this distribution LP design. Thank you.
Assalamualaikum. My name is Nur Rafika. I will present about bandpass filter using 3.4 GHz center frequency, 360 MHz bandwidth, and maximally flat, and n equal to 4. So this is a list for to do the bandpass. Center frequency equal to 0.4 GHz, ripple maximally flat, bandwidth 360 MHz, and then lower cut frequency 3.22 GHz, upper cut frequency 3.58 GHz, omega 0, omega 1, omega 2 that we calculate, and then choose n equal to 4 by value given. So n equal to 4, you 0.7654 until G5 1.000. Alright. Okay, this is calculate L1, C1, L3, C3, L2, C2, L4 and C4 by using the formula given, and then by using G1 to G5 value. Okay, this is circuit that bandpass filter using 3.5 GHz and bandwidth 360 MHz, maximum flat, and n equal to 4. And then this is a graph that frequency M1 3.150 MHz, gigahertz, sorry. M2 equal to frequency 3.407 GHz, then M3 3.7 GHz, and dB for M1 14, negative 14 and 244, and then for M2 negative 0.008 peak, and M3 negative 15.407 valley. And then okay, the conclusion is finally we perform every manual computation to produce the outcome together with optimized and circuit simulation. The optimized finding were provided. The lump distributed low pass, distributed low pass, and lumped band pass are the included designs. That's all. Thank you.